Okay, so as we start into Chapter 8, Lesson 8.1 is parabolas. And you'll notice it says parabolas review. Some of this is review in that, yes, you have done parabolas before. You've been doing parabolas since Algebra 1. Some of this is not review in that parabolas up until this point have always either opened up or opened down. Well, we're also going to now include sideways parabolas that can open to the left or right. So we go a little bit, this is officially one of our trig chapters. We go a little bit more in depth here. So as we look at this, everyone has this new chart, and I'm going to refer to this chart a lot. In fact, you're going to want to have this chart beside you as you go through homework. But as we look at it, there's what I call a left column and a right column. Because one of the big things as we go to write these equations and work with these parabolas, you need to be able to identify, okay, which type of parabola is it? You'll notice this left column are going to be the parabolas that open up or down. So the parabolas you're used to working with. Whereas the right column are parabolas that open left or right. So they're my sideways parabolas. At the top of each column is a basic equation. And if you notice this equation that is for the parabolas that open up or down in the left column, if you look carefully, notice it's a y equals x squared. So the traditional parabola you're used to thinking about, y equals x squared, is there. Okay, it's y equals x squared. You'll notice h and k represent the vertex. With a traditional parabola being up or down, remember your axis of symmetry is always a vertical line, so it's x equals a number. And notice it's always x equals the first number of the vertex. Then we're going to talk, we have a few new pieces here. And got to erase that from earlier. One thing we have is a focus. Okay, you'll notice the focus over there, it says h comma k plus p. But the focus is a point inside the parabola. Okay, it is on the axis of symmetry, so straight up from the vertex. And it is equidistant from the vertex, just the same distance that the directrix is from the vertex. And so the directrix, you'll see I have drawn in here, is an invisible line, kind of like the axis of symmetry, except the directrix is perpendicular to the axis of symmetry. So in a parabola that opens up or down, if your axis of symmetry is vertical, then my directrix is horizontal. But the point is that the focus is the same distance from the vertex as is the directrix. And so you'll notice right there the distance from the vertex to the focus is listed as the focal length. In the same respect, the distance from the vertex to the directrix is the focal length. Okay? Yeah.
So, I'm sure this is just how it looks in the picture, but is it also the same length from both sides, or does that, do you see what I'm saying?
Not necessarily. Okay, I think it's just the way the picture's drawn. So, the other thing you have here is the focal width. And the reason I say it's not, because focal width is the distance across the parabola through the focus. Well, if you look over here, focal length is p. So the distance from the vertex to the focus is p. Whereas focal width is the absolute value of 4p. And so that's why, no, it kind of looks like it's equidistant, but it's not. It's just the way this particular picture is drawn. Which, note, was drawn by me. So, human drawing as opposed to computerized. So you have all this information here, how you can find the focus, directrix, focal length, and focal width. And we'll want to use this information as we look at example problems here in a moment. The right column is for our parabolas that open left or right. You'll notice the traditional parabola you're used to is y equals x squared. A parabola that opens left and right, you're going to flip-flop the x and y. And so it's going to be x equals y squared. And so that's one good way to notice the difference between a vertical parabola or a horizontal parabola. Vertex is still hk. Notice my axis of symmetry. Instead of being x equals a number, it's going to be y equals a number because now my axis of symmetry is horizontal. And you're going to notice it's going to be y equals the y value from the vertex, the second number. There's information about how to find the focus and directrix. Notice my directrix is x equals, because with a sideways parabola, my directrix is now going to be a vertical line. And then notice focal length and focal width are now the same. Okay, so again, I'm going to try and explain more about this chart as we go through examples, but you'll want to have this beside you. I will choose now to throw in, you have a chart for parabolas. We're going to have a chart for ellipses. We're going to have a chart for hyperbolas. This is not going to be a memorization challenge. This is going to be a how do we use this chart challenge. So you will be provided the chart on the test. Okay, so it's not going to be you have to know all of, every little bit about this. It's going to be how do you use it. Okay, not memorized. Okay. Okay, let's look at example 1. And unfortunately, the way my BenQ is, you're going to see me flipping back and forth to get to that chart. Okay, we are being asked to, the big goal today is to write the equation of the parabola, given whatever information they give you. In example A, they tell me the directrix is x equals 2, and the focus is -2, 0. Now, there's a couple of ways we can go about this. One, look at that chart of information. By just looking at that chart of information, there is a way, based on what they give us, that I can tell whether this is a vertical parabola, in other words, a left column parabola, or a horizontal parabola, a right column parabola. The other option that I'll take you through also here in a moment is sketching a picture can also help you tell, is this a left column or a right column? So we need to know which equation am I going to fill in? The one at the top of the left column or the one at the top of the right column? So I need to know which column I'm working in. By just looking at that information, any thoughts if this is a left column parabola or right column parabola? Just by looking at the information. Jaden? What? A right column, so a sideways parabola? And why do you say that? Okay, that's my go-to. Notice the directrix is x equals a number. Let me flip back here real quick. Directrix in the left column is y equals. Directrix in the right column is x equals. So what does that tell me? If my directrix is x equals a number, I'm going to be in the right column. Okay? If you're not convinced, start drawing yourself a picture. I just sketch myself a little picture, and it's not that it has to be like a complete picture or anything. But we have a focus at -2, 0. So that means I'm going to have a focus at -2, 0. We have a directrix at x equals 2. And what's a directrix of x equal 2 look like? Well, that is a vertical line going through 2. Does that help you know which way your parabola is going to open? Which way is my parabola going to open here? To the left? And how do we know it's going to open to the left?
Because
The
directrix is the opposite of what's on our head.
Okay, the directrix is outside the parabola. The focus is inside the parabola. So that means my parabola is going to look like this. It's going to open left. Now, think even harder. Can you tell me where the vertex is? Why?
They all start at 0. But it's in between.
They don't all start at
But
0.
it's in between.
Okay, it's equally in between, right?
It's 2. Yeah.
Okay, so the fact that my directrix is 2 to the right, my focus is 2 to the left, what's the middle of those 2 points? 0, 0. And keep in mind, my vertex is not always going to be 0, 0, but we'll enjoy the fact that this first one allows me my vertex to be 0, 0. So this is not anything official, but there is just a sketch of my parabola. so I kind of have an idea of what I'm looking at here. So either based on the fact that the directrix was x equals a number, or based on the fact when I sketched my picture, my parabola ended up opening left, I know that this is the second column of information, right? I know when I write an equation, I'm going to be filling in the equation y minus k squared equals 4p times x minus h. Okay? So one way or another, you have to figure out which equation are we filling in. Now, when I say filling in that equation, what is it we have to know? We have to know h, k, and p. Every equation you write, you have to know h, k, and p. X and y are going to be the variables that stay in our equation. What do we already know? Oh, question? Or you got something to tell me?
Is H and K like vertex?
Yep. And if you go back to your chart, either column, HK is my vertex, right? And so, did we find our vertex by drawing that little picture? We did. So my vertex is 0, 0, which are H and K. Did I answer your question?
No,
Or-
I just asked if your BenQ saves the thing. Because you went back.
I'm going back and forth between screens. Okay, so we're okay with H and K. And what I will tell you, did you have to draw a picture on this one? Not necessarily. Some of you are going to be picture people, and you're going to like the picture for a visual. And I'm going to tell you, if you come to me for help, that's one of my techniques. Is I'm going to help you because I think you can sometimes see it if you draw a picture. Some of you are going to be like, I didn't need the picture. I could figure this out without the picture. And it's going to vary from problem to problem. Okay? Whether you can just figure it out by looking at the chart, whether you need the picture to help you along the way. So everyone's going to be a little different on that one. Okay. We have H and K. We also need P. Now I've got a couple different ways I can help you find P. You got a thought, Megan? Okay, the focal length is P. And where is my focal length?
It's the width or like the length in between.
It's the length from the focus to the vertex, or the vertex to the directrix, right? So if we go back to our problem here, can you tell the P just by looking at the picture? You can, because right here, the vertex to the focus is 2, and the vertex to the directrix is 2. Now, I will say there's a catch. This parabola opens to the left.
Negative.
It is going to be negative. So, if we think about our typical vertical parabolas, a parabola open up has a positive coefficient. A parabola opening down has a negative coefficient. Well, okay, in left-right world, compare right to the opening up, and so it's going to be positive. Compare negative to opening down, and so that's going to... Did I say that wrong? I don't know.
Yeah,
Okay,
so
I'm sorry.
Going down.
Okay, so to the right is going to be positive, to the left is going to be negative. So just realize if you just look at the picture, you just have to realize, oh, negative, P, or it's going left, negative. Okay, so my P is going to be negative 2. Now, I have one other thought of another way you can find P if you're not a picture person. And I would say you can use the directrix or the focus, either or. I personally am going to use the directrix. We were provided that the directrix is x equals 2, correct? Go back to the table or the chart. If you go back to the chart, we're working in the second column. What does it say the directrix is in formula form? X equals h minus p. So with that in mind, if x equals 2, or x equals h minus p, could you follow if I say h minus p equals 2? And what do we already know about h? H is 0. So 0 minus p equals 2, and thus p is negative 2. So if you're less of a picture person and more of a, I want to look at the chart, I want to look at the formulas, there's how you can do it. You could do a similar type thing with the information for a focus. Now, if you drew the picture, I'm perfectly fine with you saying, oh, p is 2 because that distance is 2. Oh, it opens left. It's negative 2. You find what works for you, right? Did you write your equation? That's my whole goal here, right? I know that k is 0. I know that h is 0. And I know that p is negative 2. So as I write this equation, y minus 0 squared equals 4 times negative 2 is negative 8 times x minus 0. What I will say, can I adjust this a little bit since my vertex was 0, 0? Yes. If my vertex was anything other than 0, 0, we would leave it in this form right here. I wouldn't touch it. Since my vertex is 0, 0, you can actually write this as y squared equals negative 8x. In other words, you can drop off the minus zeros on the x and the y. And in all honesty, if you left on the minus zeros, I'm not going to count you off on that. Questions on that first one? I'm making you work this first day back, aren't I? I make you think. Okay, let's try the second one. Vertex is 3, 4, and focus is 5, 4. Again, I can draw a picture, or I can look at the chart. But either way, it's pretty easy to tell whether it opens up, down, or left, right.
It is. How do you tell with the focus? I don't like that H, the HK plus P or the H plus
So, okay, so if I'm looking at my chart, notice vertex is 3, 4, and vertex is 5, 4. Which number do they have in common?
4.
They both have 4. So if I go over to my chart, over here in the left column, when you look at the vertex and focus, they have H in common, but not K, because it's K and K plus P. Over here in the second column, it's H and H plus P, so the first number is not in common, but what do you notice about the second number?
The second.
It's K and K.
So
So that means that this parabola is another second column parabola. It's going to open either left or right. Now, if you are not at all for what I just did with the chart there, what am I going to say?
draw a picture.
Draw a picture. And you don't even have to draw the full picture out, guys. You just have to visualize enough to know what you're doing. The fact that, let's see. At 3, 4, I have a vertex. At 5, 4, I have a focus. You'll notice I labeled V on vertex, F on focus, because otherwise I don't know which is which. Okay? If my vertex and my focus are next to each other sideways, what's that say about my parabola? It has to open left or right, doesn't it? And which way does it open, specifically? To the
Right. Because it's
Right.
going towards the focus.
to the right, because my vertex, I'm going to have my focus inside my vertex, or my focus inside my parabola. Let me know if I'm not explaining myself well. And I just sketched a random parabola in there.
Oh, it's the direct, whatever the other one is. That can't be inside of it.
Right. The directrix, they didn't give us, but it would be over here at the left and be a vertical line.
Okay.
Okay, so they gave me my vertex, which means what did they give me by giving me my vertex?
H and K.
H and K. Now, let me also state, which equation are we filling in? This vertex or this parabola opens right, so again we're going to be filling in y minus k squared equals 4p times x minus h. I like to write that equation out so I have it there in front of me and I know which one I'm filling in. What else do I need to know?
P.
P. Thoughts about P?
2.
Why?
I just counted the numbers.
If you're a picture person, does that work? P is the focal length, which is the distance between the vertex and the focus, which, based on that right there, P is 2. Here's my other thought real quick. Again, and I'm trying to give options here, because sometimes the picture doesn't work, sometimes the chart doesn't work. If you go to the chart, and if you go, whoops, wrong way. If you go to the right column of the chart, it says the focus is H plus P, comma K. So that means it makes sense that K is 4, and what does that mean H plus P is? H plus P has to equal 5. But we already know H is 3. So 3 plus P is 5, and thus, does that support the fact that we claimed P was 2? Okay? Again, I don't care which way you guys do this. I'm giving you options. I'm just trying to make connections for you. Okay, did you write your equation? What do we know? H is 3, K is 4, and P is 2. And it makes sense that P is positive 2 because this parabola opens to the right. Okay, so I'm just going to write this and leave it. Y minus 4 quantity squared equals 8 times x minus 3. Yes, Allie?
Does the P stand for point, parabola, is it point? Or does it really have a thing that the P stands for? Or is it just a variable?
I don't know if P has something it stands for. I mean, other than it's the focal length. I'm sure there's a reason P, but I don't know.
Okay, did
But-
I like miss something?
I don't have an answer for you there that defines it. Maybe I should, but I don't off the top of my head.
That's okay. I just
So.
wanna make sure.
Nope, I don't think you missed anything.
Okay.
Not a connection I made, at least. Okay, C. I will say on C, I didn't draw a picture. I feel like this one, all the information is given and kind of, is there. It opens left. The vertex is negative 3, 2, and the focal length is 2. What kind of information can you give me there?
We're in the right column.
Okay, we are in the right column because again it opens left. So that means I'm going to be filling in y minus k squared equals 4p times x minus h. Okay,
H and K.
they give us the vertex, which means they give us HK,
And P.
and they give us P. It says focal length is 2, and so that means P is 2. One other detail we're overlooking. -2. The focal length is 2 because length is a distance, and so they're going to give me a positive there. But how do I know P? We have to use P as -2. It opens left. So because it opens left, you have to automatically think, oh, P is going to be negative. And so we're actually going to use P as -2. Is that one not too bad now that we've seen all the others? Okay, write your equation if you haven't already. Y minus 2 quantity squared. 4 times -2, so -8. X minus -3 means I'm going to write X plus 3. And I guess I never wrote in those values there, did I? But I think by this point you guys are catching on. In homework, you're going to see a large variety of these. They won't always be right. They won't always be the second column. You will have some first column ones thrown in too. Okay? You've seen a variety. Hopefully you're starting to see how you can make the connections. Obviously there's going to be some different ones. Try them, do them, see what you can come up with. And then we'll talk about questions on this stuff tomorrow, on this particular page, type of problem tomorrow. Okay? I do need to go to the back side because there's a back side. So, not done yet, but just saying that, this is going to be the bulk of the homework, this type stuff. Work on making these connections. Okay, as you get this stuff figured out, this will carry over into ellipses and hyperbolas, which are our next 2 sections. Okay, do we have what we need from this page? Okay. Next page, backside. Graphing a parabola on a graphing calculator. Those ones on the front, I couldn't graph on a graphing calculator because why? What has to be true to graphing on a graphing calculator?
An equation.
An equation that's in what form? Y equals, right? Those ones on the front were not Y equals. These ones on the back are not Y equals. So what's your job?
To get it Y equals.
To get it Y equals. So there's a few basic steps up there. Solve for Y. Note, sometimes you might have to complete the square. Hopefully we have time to get to example C here. That will be important. Then it's just typing the equation into Y1. And notice it says, and sometimes Y2 when you have to square root. So there's a hint. And then push the graph button. So let's practice solving these. These are each of these 3 examples are a little bit different. So I'm kind of hoping we can get through all of them. We'll see. A. Thoughts on how to solve for Y? If it's Y minus 4 quantity squared equals 8 times X minus 3. Yeah, when you have Y plus or minus the number quantity squared, my job is to square root. If I square root the left, we square root the right. So, what happens when you take the square root of Y minus 4 squared?
It goes away.
Okay, we're going to have Y minus 4 equals, what's the square root of 8 times X minus 3? The square root of 8 times X minus 3.
Can we simplify that?
Plus or minus. So, okay, a couple of things here. First of all, you must get the plus or minus on there because what did we just do? We took the square root and then equation setting. So when we take the square root of both sides, you have to throw a plus or minus in there. In terms of under that square root of 8 times X minus 3, you could distribute. It's not necessary. Okay? Because you can type it into here's the deal, we're going to be typing this into the calculator. Can you type in 8 times x minus 3?
Yeah.
You can. Okay. In terms of simplifying, could you pull out a perfect square of 4 from the 8 there and make this 2 square root of 2 times x minus 3? You could, but again, not necessary. You can plug it into the calculator the way it is. Now, what is the last step I do have to do, though? I haven't solved for y fully yet. If it's y minus 4, we're going to add 4. If I add 4 on the left, add 4 on the right. If you recall, I prefer to have my plus or minuses in between two items. So I'm going to write this as y equals 4 plus or minus the square root of 8 times x minus 3.
Can you put that on the back?
Can you what?
Could you put that plus 4 or minus 4 on the back?
You could. If you put the 4 on the back, it'd be plus or minus the square root of 8 parentheses x minus 3, and then a plus 4 after the square root. The plus or minus has to stay in front of the radical. Now, what about when you type this into your calculator? Where's your plus or minus button? Right, there's not one. So you're going to have to type this into your calculator as a y1, which is, on mine, 4 plus the square root of 8 times x minus 3, and a y2, which is 4 minus the square root of 8 times x minus 3. Okay? If you don't type both halves in, you're not going to get the full parabola. But when you have sideways parabolas, this will often happen. Okay? How do you show me that you graphed this? You sketch a graph, right? Now, in all honesty, if you caught it, you know the vertex from the original problem. Do you see the vertex here? Mm-hmm. With the x as a minus 3, so it's 3. With the y as a minus 4, so it's 4. So you can tell by looking at the original equation before we did anything that the vertex is 3, 4. If you take your number from your x and your number from your y. Can you also figure that out by trying to do some tracing and stuff on your calculator? You can. When you sketch your graph, try and figure out approximately where that vertex is. And if you can, try and figure out, like I think this one crosses the x-axis at around 5 maybe. It makes it for a very wide parabola on my graph, but try and put some pieces in there that make it look like you've put a little effort into figuring out what this parabola is doing.
What if mine doesn't work?
Did you type something wrong? The 4 stays plus both times. It doesn't change. So if you do down there, you should just do it. Yeah. That's probably what yours is. Yep. Yeah, yours should look like mine. If it doesn't, you've probably typed something wrong.
Yours is really wide.
Well, it's the I don't know. It's the way I had mine drawn. It doesn't look as wide up on the calculator, so.
Yeah, mine. Oh yeah, mine doesn't even touch the x-axis.
And see, technically, if you look at your calculator, it's supposed to go through the x-axis around 5-ish.
Whoops.
Which is why, I wasn't really set up for that, but I made it happen. And it turned really wide in the process.
It looks like C.
Yeah, theirs just looks so much better.
I know, it does. Okay, B. When you look at B, what do you notice in terms of y? There is one y term, yes? And it's just a plain old y. Y to the first. Happens to be a 3y to the first, right? Use your basic equation solving skills you've been using since middle school. How do we get 3y by itself? And so if I'm going to get 3y by itself, I'm going to start by moving everybody over. So I'm going to subtract x squared add 7x, and add 2 all over to the other side. Okay? Or move your 3y and make it negative 3, but I would prefer keeping a positive 3y. So I moved everybody over. When I clean that up, I'm going to have 3y equals negative x squared plus 7x plus 9 and 2 adds to be 11. And then how do I get y by itself? I divide by 3. Again, I'm typing this into a calculator next, right? So I'm just going to write this as one big fraction. Y equals negative x squared plus 7x plus 11 all over 3. Okay. I want to get on and look at C real quick. I have faith you can type this in your calculator. And if those numbers had divided by 3, by all means, I would have divided them by 3, but none of those divided nicely by 3. So that's why I just made it one big fraction. You do end up, when you graph this, notice it's y equals a negative x squared, so you do end up with an upside down parabola, yes? You end up with your vertex being up around 3.5, almost 8, not quite, 7.75. I'm going to trust that you guys can put it in the calculator and figure that out. Okay? I want to look at C. So if you can catch up with me real quick so we can look at C. And the reason I want to look at C, what do you notice in terms of y terms? There's 2 of them, but they're not both y terms. There's a y squared and a y to the first. This is when you have to complete the square. Is when you have a y squared and a y to the first. Because we're going to complete the square, and then this problem is going to be a lot like A. So, in order to complete the square, start by getting your y squared and y terms on the left. Everybody else to the right. So, I'm going to add my 6x over and subtract my 13 over. And when I do that, I'm going to have y squared plus 2y. I'm going to leave a blank, or a gap. A gap is what I usually say, right? Equals 6x minus 13. How do I complete the square? B over 2, quantity squared. What's my B?
6.
Not 6.
Not 6.
2. So 2 divided by 2 is 1. 1 squared is 1. I'm going to add 1 on the left to complete the square. If I add 1 on the left, you add 1 on the right. We want to keep both sides balanced. We're working on opposite sides. When you're working on just one side of the equation, you add and subtract on just one side. But since I'm working on both sides of the equations, what I do to one side, I do to the other side. Now, the idea after you complete the square is that that left side factors into parentheses squared. Does this sound familiar? The square root of y squared is y. The square root of 1 is 1, and the sign in front of 2 is a plus. Or you can just think what multiplies to be 1 and adds to be 2, and that's 1 and 1. So y plus 1, quantity squared. The right side I'm just going to clean up in 6x minus 12. And then you solve this just like we did on example A. If it's y plus 1 quantity squared, we're going to square root. If you square root the left, you square root the right. So y plus 1 equals, nice, plus or minus the square root of 6x minus 12. And then, of course, you subtract the 1 over. And I have y equals -1 plus or minus the square root of 6x minus 12. Like example A, you're going to have to type this into 2 places. Could you factor that 6 in the parentheses? You could. And I would say it's not necessary, although it's actually helpful because it will show you a little bit of where your vertex is. If under that square root, I say 6 times x minus 2, my vertex, the x value is going to be 2. My y value is going to be this -1 out here. And so you end up with a sideways parabola that goes through the vertex 2, 1. That was timing and a half. Okay, guys, homework is down here. Make sure you write it down. Make sure you go in and try the homework. Yes, it is due tomorrow. We will go through questions, obviously. And then we'll also start into ellipses tomorrow. I say start into ellipses. We won't get through them.
That was my phone going wrong.